In our last set of notes, we're going to talk about geometric probability. So you need to remember that theoretical probability is what should happen in an event. So like if I flip a coin 100 times, theoretically it should land on heads 50 times and on tails 50 times. Chances are that's not going to happen, and that's called experimental probability, but in this we're only dealing with geometric. So theoretical probability has an equation, and what we're going to do is basically divide some stuff. So the probability is the number of outcomes in the event and the number of outcomes in the sample space. So let's think about what those two things mean. The event is what we want to happen, and the sample space is the possibilities. So if we think about the coin example again, if I want heads, there's only one head on the coin, so that would be my event. But there is two possibilities, or that's your sample space. It could be heads or tails, so the probability is 1/2. So here's what we're going to use for geometric probability. You're either going to find it for length, for angle measure, or for area. So for length, the sample space is going to be all the points possible. The event is going to be the points that we want, and to find the probability, we're just going to divide. Angles are a little easier because every angle has a circle. The probability is going to be however big the angle is divided by 360 degrees because there's always 360 degrees in a circle. For area, you're going to find the total area of the shape, and that's going to be your sample space, and then your event's going to be whatever they say. So for this, they wanted you to find the probability that it hits a triangle, so you'd find the area of that triangle. So let's do some length ones. A point is chosen randomly on WZ. Find the probability of each event. So the first thing you should do is find out how long WZ is. So 2 plus 5 gives us 7, plus 3 is 10. All of our denominators are going to be 10. So for number 2, it says, what's the probability that the point is on XZ? So from X to Z is 8. 8 out of 10 is 80%. For number 3, the point is not on XY, so we don't want XY there. It could either land here or here. So 2 and 3 gives us 5 out of the total of 10, or it's a 50% chance this happens. And the next one, the point is on WX or YZ. So WX is 2, YZ is 3. So this one's the same, 5 out of 10. Or 50%. And then the last one, the points on WY. So W to Y, if you look, has a total of 7 out of 10. So this is a 70% chance. So angle measure, remember the only difference here is you don't have to figure out the total. You know the total angles in a circle add up to 360. So that's going to be our denominator. So I know you don't have the colors on here, but you do now, so you can write little letters next to them if that helps you. The probability that the pointer lands on green. Well, if we look, the green part has 45 degrees devoted to it, and that's out of 360 total. So if we throw that in our calculator, we get about 12.5%. The pointer landing on orange or blue, so just like before, we got to add those up. Orange or blue takes up a total of 45 plus 90 degrees, or 135 out of the 360 total. And then all we got to do is divide, and we get about 37.5%. The next one's interesting because it wants the probability of it not landing on red. So red takes up 120 degrees. So if we subtract that from 360, that means that there's 240 degrees that aren't red. And that's what we're going to divide by 360. And when we get that, we get about 67%. So 67% of the time, the spinner will not land on red. And then we have the last one, landing on blue or yellow. So again, add them up. Blue or yellow takes up 150 degrees out of the 360 degree total. Throw them in our calculator, and you get about 41.7%. Hopefully not too bad. Very last part is area. And it says, find the probability that a point chosen randomly inside the rectangle is in each shape. Round to the nearest hundredth. So the first thing we gotta do is figure out the area of the rectangle. So let's go back to our area formulas. Rectangle is just base times height. So in this case, it's going to be 24 times 48. And if we multiply those together, we end up with 1152 feet squared. So remember, that's going to be our denominator. Let's go through and figure out the area of each one of these other shapes. Remember, a triangle is 1/2 base times height, so we'll have 1/2 10 times 10. 10 times 10 gives you 100, and if you cut it in half, you get 50. Let's find the area of the trapezoid. This is one people always forget, but remember, you add your two bases, so 12 plus 18 gives us 30. You multiply by 6, and then you chop whatever you get in half. So you end up with 30 times 3, or 90 feet squared for the trapezoid. Square is nice and easy. Remember, that's just base times height, or 10 times 10 in this case. So you get 100 feet squared for that square. And then it says the part of the rectangle that does not include the square, the triangle, or the trapezoid. So what we're going to do is take this total of 1152 and take out the 50 feet for the triangle, take out the 90 feet for the trapezoid, and take out the 100 feet for the square. So there's 912 feet squared left. So now remember, it didn't just ask us to find the area, or this would have been in a previous section. It asked us to find the probability that it hits one of those things. So for the triangle, number 12, we're going to take 50 and divide it by the total rectangle. And when you type that in your calculator, we'll get a small decimal because the probability is not large, but it's about 4%. Number 13, we should expect to be a little higher, because there's more trapezoid in there, but still, comparatively, it's not that big. And we get about 7.8%. Number 14, the square, we should expect it again to be a little bigger, but not huge. So that's 100 divided by 1152. And we get about 8.7%. And then finally, 15 should be our biggest one yet, because that's most of the shape. Most of the shape is just the rectangle. So that was the 912 we had to find, divided by 1152, and you end up with about 79%. The other way you could have found that one is added up all of these percentages that we just found and subtracted them from 100. So whatever way makes more sense to you. If you have any questions, make sure you jot them down and I can answer them tomorrow. If not, enjoy your day.